Hmm. Okay, here we go. Looks like we got 2 in the room already. We got a like. Always appreciate the likes. Alrighty. Alright, so moving right along. Welcome to Military Aptitude and FAA Test Prep Live. This is Kino with STEMwithKino.com, and I'm ready to answer some questions. Avery's checking in. Good to see you with the Armed Forces Officer Qualifications Test Preparation. And I'm looking at this question. Let's see here. Okay, Maria's in the building. All right. Let's drum up some question, guys. Now, Okay, number 25. One printing press can do a job in 8 hours. Another printing press can do the same job in 12 hours. How long would it take both presses working together to do a job? Okay, so this is what I call a working together problem. A working together problem is set up like this. We'll have an X plus X and equals one job. Now we place the number of hours in each of these bottom sections. All right, so one job can do the work in 8 hours. The other one can do a job in 12 hours. Just making sure I'm writing this down correctly. So basically what we're going to do is we have to deal with each term. All right, we have to deal with this, we have to deal with this, and we have to deal with this. And in this case, unlike how we work our fractions or addition of fractions with the cross multiplication, we have to find the lowest common denominator and multiply by such. And to me, it appears to me that 24 is the lowest common denominator, because 8 times 3 can be 24 and 12 times 2 can be 24. Do you think I can? I'm sorry, I got distracted. I'll answer that in a minute. Somebody sent me a question. All right, so 8 times 3 equals 24, and 12 times 2 is 24. So we're going to multiply every term by 24. All right, and this is like multiplying by 24 over 1. So this is going to actually turn into a 3x. And this is going to turn into a 2x. And then 24 times 1 is 24. So we will actually have 5x is equal to 24. And then we have to divide 5 on both sides. So we have, it's going to be 4 point something hours. I can see that. 24.0, 4, 24 point, or the 0 drops, 40. So 4.8 hours. Now, they don't give us the answer in decimal hours, if you would. 4.8 hours. They actually give it to us in hours and minutes. So when we are trying to find the number of minutes, just look at the 8 and multiply by 6, and that will give you the minutes. So this is 4 hours. Both presses will do the total job in 4 hours and 48 minutes. 4 hours and 48 minutes. Okay, so to recap, we had, let me just run the question again. One printing press can do the job in 8 hours. Another can do the same job in 12 hours. How long will it take both presses working together to do the job? So what we do is we set up the two presses like this. So X plus X. On the bottom represents the number of hours each one can do the job, and they're being added to work together to complete one particular job. What we did was we found the lowest common denominator, which was 24, because 8 times 3 is 24, and 12 times 2 is 24. So we multiply each term by 24, and we came up with 3x plus 2x equals 24. At that point, we combine like terms. 3x plus 2x is 5x equals 24, and we have that down here. We divide 5 by on both sides. The 5's cancel out here, and x is equal to 24 divided by 5. We go over here, we divide 24.0, same thing, 24, divided by 5, and we come up with 4.8 hours. Again, the answers don't say 4.8 hours. They say 4 hours and 12 minutes, 4 hours and 24 minutes, 4 hours and 36 minutes, 4 hours and 48 minutes, and finally E, 5 hours. So how do we determine the number of minutes? Well, the whole number is going to be the number of hours, but when we're trying to determine the number of minutes, we look at the number in the tens place, we multiply by 6. 8 times 6 is 48, so our answer is 4 hours, 48 minutes. Okay, if you didn't get that, this is DVRable, and let's have another question. All right, and I will check my mail again. All right. Okay. Okay, just answering an email for a second there, coming back to the email. All right, this is an interesting one. All right, I don't know if we've done this one on the stream before, but the question reads as such. At 12 noon, 2 vessels started sailing towards each other from 2 ports. So we have boat 1 and we have boat 2. All right, they start sailing towards each other from ports that are 450 miles apart. So the distance between these two is 450 miles. All right. They travel at average rates of 22 and 28 miles per hour, respectively. So we'll give this guy 22 mph and 28 mph, miles per hour. So at noon, they started traveling towards each other. And they want to know how far apart are they going to be at 8 o'clock. So what we need to determine is the closure rate. It is the combined speeds of the 2 vehicles. 22 plus 28 is 50. All right. 20 times 20 is 40, and then 2, 8, 50. All right. So the closure rate is 50. In 8 hours. All right, let's look at 40, 50. So they start traveling towards each other at a closure rate of 50 miles an hour. And how many miles apart will they be at? They'll be 50 miles apart. If the closure rate is 50 miles per hour, that is the speed that these two ships are closing at each other. In 8 hours, they will have covered 400 miles. So we subtract that from 450, and that will give us initial distance of 450. And then we subtract 400 from 450, and that leaves 50 miles. So that's how far they will be apart. All right. To recap, we have 450 miles. Now, it would take much longer if you said, okay, well, this guy runs 22 miles per hour for 8 hours, and then multiply this by 8. Just combine the two speeds, multiply by the number of hours they move, and that will result in the total distance that the two vehicles, ships, trains, whatever the object is, all right, which is 400 miles. If we started at 450 and we move 400 miles collectively, then we only have 50 miles remaining between the two. The answers were 125, 100, 75 miles, 50 miles, and 25 miles. So the answer is D. And if that's clear, guys, please type in clear if you guys got that. All right, Osvaldo, don't mess with Texas. No problem. Now, the other one you sent is... Oh, he's LOL. But, hey, look, man, look at my... Listen, real talk. My mother lives in San Antonio, Texas. And she sent me this, don't mess with Texas. That's why I always say it. She sent me this. Actually, I don't know. I think I might have taken it off her refrigerator. It's like, hey, Mom, I'm taking this, don't mess with Texas. So I'm true to the game, man. Shout out to my mom. Love you, Mom. I got your refrigerator sticker. Okay. That's what's up. Okay, our next question. And I appreciate everybody coming out. Please hit that like button. I gotta be like the other guys on YouTube. Please hit the like button. 2 trains are 630 miles apart. At 9 a.m., they start traveling towards each other at an average rate of 50 and 55 miles, respectively. At what time will they pass each other? Now, again, we diagram as we go. 2 trains are 630 miles apart, so I'll just make a little... This is not... Well, we'll just make 2 little boxes that represent trains. Or no, I'll make it the Amtrak train. There we go. The Acela Amtrak trains have that little cone shape. Wow, that kind of looks like something else. Okay. All right. These are 2 trains. All right. One is moving at 50 miles an hour and one at 55. They are 630 miles apart. 630 miles apart. So, a way we could handle this is we want to know at what time they're going to come into contact with each other. All right. So, I do this kind of like, I'm going to try to do this like an expansion problem. Our answers are 1 p.m., 1:30 p.m., 2 p.m., 2:30 p.m., or 3 p.m. Now, they start moving towards each other at 9 o'clock, and let's see how long it is going to take them. So if I do this like a expansion problem, because the expansion problem would work like this, where it would say we have 2 trains moving away from each other, how long is it going to take them to get 630 miles apart? Well, we could do the reverse, or do the reverse. How much time is it going to take them to kiss each other, if you would, or pass each other on opposing rails? So we have 105. That is a combination of 50 and 55 equals 630. And I see 6 hours right off I see 6 hours at this point. Because if we take this, we multiply, or we say we have 105, which represents 100, and then 5, right? If we multiply this by 6, we would get 600 miles, and we multiplied the 5 by 6, we would get 630. So T is equal to 6 hours. If we started driving towards each other at 9 a.m., then we would cross each other 6 hours later, which is 3 p.m. 3 p.m. All right, and 3 p.m. is selection E. All right, so you do this, you work this just like an expansion problem. 50t, which is 50t, which is the rate times the unknown time plus rate times unknown time, we combine them together. And after combining them together, we divide both sides by 105. Now, I saw 105. I already saw 6 hours because I broke down the 100 times 6 hours will give us 600 miles, and then a 5 times 6 will give us 30 hours, i.e. 630 miles. And so it would take us 6 hours for those 2 trains. So you work it just like an expansion, distance, rate, and time problem. And this is a physics problem. This definitely is a physics problem, so make no mistake about that. All right. All right, folks, more questions. Let's have them. Nothing, Maria? I got one for all of you. We were talking about, in the last Google Hangout, we were talking about first class levers or lever systems. Lever systems, lever or lever. All right, so we have a plank. We have a fulcrum in the middle. And in a lot of these cases, what the questions will do is they will give you a load on this side, and or maybe not an effort, but they will say, okay, you have 600 pounds and this is 4 feet away. And they may ask us, how much weight must we place at 12, let's say 12 feet away from the fulcrum on this side? All right. And Maria and I, we were doing these problems today. So basically what we have to determine is the load moment. What is a load moment? A load moment is a function, or it is the, what's the word I'm looking for? I forget the multiplication. The product. There we go. Load moment is a product of 604. Now, if I'm multiplying 604, I don't really need to do any fancy math. I know that 6 times 4 is 24, and then add the 2 zeros. That's my rapid math technique. So I'm producing on this side, with 600 pounds being 4 feet away from the fulcrum, I'm producing a load moment of 2,400 foot-pounds. All right. Now, if I'm producing a load of 2,400 foot-pounds, the question is asking, how much weight do I put on this side of the fulcrum? And we think of the fulcrum like an equal sign. In order for there to be balance, the load moment on this side has to be equal to the load moment on this side. So how do we get load moment? It is weight times distance. So how much weight can we place at 12 feet? Well, that's very, very easy. Whether they give you distance or they give you weight, just find out the load moment and divide by the distance or the weight given. All right. So ready? It is 2,400 divided by 12, 2400. And my answer is going to be 2, because 200 or 200 pounds If 200 pounds is placed at 12 feet, we will produce a load moment of 2,400 pounds on both sides. So we have a downward vector of 2,400 pounds here and a downward vector of 2,400 pounds, foot-pounds, I'm sorry, because 200 times 12 is 2,400 foot-pounds. Thus, we have 2,400 pounds on both, or foot-pounds. I'm sorry, I keep saying that. Foot-pounds, foot-pounds. So that's how we get the system to balance. So the question would not ask it, wouldn't have the 200 foot-pounds. It will show you 600 pounds at 4 feet, and then show you a reference at 12 feet, and just ask you how many pounds. You got 20 million, 200. 12 times 2 is 24, and then add the 2 zeros. Okay, you corrected yourself. Okay. So that is a very, very important skill to have, especially if you're going to be taking the aviation selection test battery, because it can cover the first, second, and third lever classes, and you will have to know how to manipulate these questions. All right. Come on, Avery. I know you got something else for me. I know you got something else. And she's not bad. I call her my problem child jokingly because she always comes up with some interesting questions. All right. More problems on gravity. Gravitational pull. Okay, collectively, we will speak to the room about gravity. Gravitational pull. Let us ask some questions. Gravity problems. We could do gravity problems by thinking about potential energy. Let's take a look at this. Potential energy, or energy, PE. Can you guys see that ink? It looks light to me. All right. I'll use a darker marker. Equals mass times gravity times height. The mass is in kilograms. The gravity is 9.8 meters per second squared, and the height is in meters. All right. So the potential energy is going to be in joules. All right. So what is... Oh, hold on. Let me, shoot. I can come up with some real... potential energy problems. And I'm not crazy. I'm just talking to the computer. All right. And let's go to some images. Okay. Now, the question is asking, what is the potential energy of a rock? Of the rock. Not the wrestler. If you smell what the rock is cooking. All right, so what is the potential of energy of the rock? What they have is they have a hill up here, and it's going downward. And the rock is up here, and it is 100 meters high. All right. So what is the potential energy of the rock? And for my people in the room, this is a 95 kilogram rock. 95 kg. All right, so we're going to calculate potential energy. All right. So what is the mass, folks? Just type on the timeline for me, guys, if you see what the mass is. They could be, Avery, but this is not bad. This is not bad. It's very, very easy. All right. The question would ask you, okay, you have a object, 95 kilograms, 100 meters high. All this is plug and play. All right. So we would have 95, but we got to multiply by 9 because it's mass times gravity times height. So that is a very, very good rapid math technique to use. Add 2 zeros to the 95, and then that would give us 9,500, and then multiply by 9.8. So you're halfway there, Avery. 95 times 100 is 9,500. Now we have to multiply by 9.8. So 9,500 times 9.8. I'm not going to deal with those zeros. 9.8. I just have to remember to do my due diligence here. So, all right, 40, 49, 0, 72, 7, 89. All right, so 0, 11, 14, 9, 4, 1, 0. We got to put our zeros back. All right. So after we put our zeros back, then we move in 1 decimal point, and it should be 94,100 joules. And I made a mistake there because the answer, let's see, 1. No, they made a mistake. All right, 0, 9, 2, 72, 40, 45, 49. They made a mistake. All right, we corrected a mistake. So 94,100 joules. Sometimes be careful because sometimes joules can be called Newton meters. All right, but a Newton meter is a joule. All right, so that's how you could get a potential energy, but it's just plug and play. It's multiplication. 95, which is the mass, times gravity, which is 9.8 meters per second, times height, which is 100. We did a rapid math trick by multiplying 95 times 100 and just adding the 2 zeros and then multiplying by 9.8. I chopped the 2 zeros off, did the math, added the 2 zeros back, and brought it in 1 decimal point. Answer is 94,100 Newton meters or joules. Okay. So that is that. Okay, we're about the halfway point, guys. You got me. Abuse me. Ask questions. That didn't sound right. Abuse me. Don't abuse me. You guys know what I meant. I can't see the formula. Okay. Welcome to the room, Cody. Mass times gravity times height is the formula for potential energy. Then this is a big E, and then in subscript we have PE, which means energy, but the type of is potential energy equals M times G times H, which is mass times gravity times height. Good to go there, Avery? Okay. Another gravity question could be, they could ask you a kinetic energy problem, but let's do one more. And Avery, I want you to definitely do this and deal with the plug and play. Okay. A 15 kilogram textbook is sitting on a 1.2 meter tall table. All right. Now, this is a trick question. I won't do that one. Or I will do it. I will do the trick question. All right. So, again, this is a word problem. All right. And you have to listen to the wording. All right. We have a 15 kilogram textbook. It is sitting on a 1.2 meter tall table. So we have a table and we have a book. This book is 15 kilograms. All right. And the table is 1.2 meters high. All right. So if the book is lifted to 0.8 meters above the table, so we actually got to go 0.8 above the table. If we raise that book in the air, you take your hand, you lift the book up. How much potential energy does it have? Now, I want you guys to give me the setup formula. All right, mass times gravity times height. So don't execute the problem. Just tell me what the mass is, what the gravitational pull is, and what the height is based on this question and based on the formula for potential energy. I'll wait for you guys. $15 times 9.8, 1.2. Okay, somebody else? Anybody else want to add what they think the formula setup is? Don't be shy, folks. You do have to add the 0.8. So if you raise this off the floor, it was positioned at 1.2 meters above the floor because that's how tall the table is. Then we have to add the 0.8. So it'll be 15 times 9.8 times 2. (15 times 2). Osvaldo, what are you confused about? Okay, so we have to remember the floor is here. The book was 1.2 meters above the floor already. But then when we raise it up against 2.8, then we are a total of 2 meters above the ground now, or above the floor. All right. And Maria answered it. She answered it. 294 joules. That is the potential energy. Good job. Good job. Here's a good one. That answer was 294, guys. Let's make a little apple tree. Here's our apple hanging from a branch. All right. And I want you guys to do this. This apple is 55 grams. And it is 3.5 meters high. What is the potential energy of the apple when it separates from the tree? This is a trick question as well, guys, so be afraid. Be very afraid. You have to add the 1.2 plus 8 first. Yes, you do, Osvaldo. I'm just coming in a little bit late on that transcript there. But what I want to know is the potential energy of this 55-gram apple 3.5 meters above the ground. And this is a trick question, so try to see how this question is trying to trick you. Hey, you want gravity questions? I found some. Okay, let's see. 55 times 9.8 times 3.5. How many in the room agree with that setup? I don't know how to do it. It will be all multiplication, hon. It'd be all multiplication, provided the numbers are right. But does everybody else agree with that? Let's see if one more agrees. And please hit the like button, guys. Yeah, I did say it's tricky. Okay, I guess. Okay, so we got 3. We'll go with that. Okay. The problem is, if we go back to what I told you guys about the formula and why I say it's tricky, is because we said that the formula was mass times gravity times height. We have to pay attention to the meters because the testing will do this to you. They will give you a weight in grams. Okay? And that's not the formula. The mass is in kilograms. So the 55 has to be converted to kilograms, all right, in order to proceed with the question and come out with the proper number of joules. So I know changing from grams to kilograms, the decimals right here, and we go 1, 2, 3. So we would have to multiply by 0.055 kilograms, because that's what 55 grams is equal to. And when we multiply 0.055 kilograms times 3.5 meters, and then multiply that by 9.8, because we can't forget gravity, 9.8, then that will give us the answer. So that was not the proper setup. The proper setup is mass, which is 0.055 kilograms times 9.8 times 3.5 meters. So anybody have an answer for me? 0.055 kilograms times 9.8 times 3.5. And that will yield our potential energy in joules. Come on, any takers? Anybody got an answer yet? I'll wait about a minute. Avery's got an answer. I'm looking for one more answer. Do we agree with Avery, folks? Don't agree. I suck at math. It was tricky because we had to convert to kilograms. Okay, Maria came up with the same answer, and you guys are both absolutely correct. All right. But you guys have to watch units. You got to watch units, because they will do that. They will put that on the test. They won't give you kilograms. They'll give it to you in grams. And then if you aren't paying attention and you just execute an answer with the 55 grams, what's going to happen is they will have the answer using 55 grams on the test. I guarantee it. They will have it. It's what I call a sucker punch. All right. Like you got sucker punch. You know, you dipped and boom, you ain't protect yourself. And then pow, you got popped in the jaw, because that should not be in grams. It should be in kilograms. Now, what is the memory aid for converting grams to kilograms, or grams to milligrams, or kilograms to milligrams? The memory aid is King Henry died by drinking chocolate milk. King Henry died by drinking chocolate milk, and you will have to go to my video on conversions to figure that out. All right. And that will help you convert. Okay. All right, let's have at it, guys. You're welcome. Can you do a square root question? I most certainly can. All right. I most certainly can do a square root question. Okay. Let's try some different types of square root questions, because we do a lot of simplifying, but we don't. All right. Okay, as you recall, let's see, let's do this. So let's say we have -5 root 6 minus 2 root 6. This is very, you treat it like you have -5a minus 2a, which would be -7a. So guys, what would be the answer to this question if we treat it like that? Oh, I'm tired. No answers, guys? Avery? Very good, Maria. Does everybody agree? Does everybody see how that happened? -7 root 6. Okay. Avery came with it too. All right. Now, let's turn up the heat. How would I do? Well, I'll execute the problem. Sometimes you would have -3 root 24 minus 3 root 2 plus 2 root 2. Okay, now normally under normal circumstances we would probably deal with the root 2's, but we have an issue here. The issue that we have here is that this guy ain't in the same family. He's different. All right. So probably what I would do is try to make a likeness. All right. If it is possible. It may not even be possible. All right. So if we factor 1 and 24 equals 24, 2 and 12 equal 24, but we don't have a hot number. 3 and 8, but we don't have a hot number. We get to 4, we have a hot number. So this -3, this is like saying -3 times the square root of 4 times the square root of 6. minus 3 root 2 plus 2 root 2. This breaks down into a 2, so this is saying negative 3 times 2, so this is negative 6 root 6, and the negative 3 and the root 2 and the positive root 2 will just come out to a negative root 2. So the final answer to negative 3 root 24 minus 3 root 2 plus 2 root 2 is negative 6 root 6 minus root 2. Is that clear to everybody? Very good, Maria. Does everybody see that though? I'm tired. I understood what you meant, Avery. It's totally fine. I understood what you meant. Okay, let's try another one. All right. Negative 3 root 45 minus root 5 plus 2 root 2. What do you guys think the answer is, folks? And I'm assuming you guys are working on this problem. I'll give you guys a couple minutes. I'm tired. And Maria, we're probably going to save the combination ones that you're asking for the Google Hangout. Because we're almost out of time. But I want to work this problem out for the public. And whoever wants to be involved in the Google Hangout, please send me an email. Negative 10 root 5 plus 2 root 2. Boom! Maria is not playing tonight, y'all. She is not playing. She is like Kobe Bryant on these square roots. Oh. Wow. Okay, does everybody agree with Maria? Well, I guess based on my reaction, you could tell. Then she got it right. But yeah, negative 10 root 5 plus 2 root 2. That's it. Okay. So if you're a client of mine, and if you're a client of mine, you're welcome to come to the Google Hangout. You just got to send a request, and I will honor the request and send you an invite. Maria, real strong tonight. Really, really strong. And like I told you, your math, it's only going to get better. It's not going to get worse. Practice makes perfect. So, yes, I certainly will. So, you know, I know that, some people may be looking at the math on this video and they're like, wow, that's like it's really not that hard. It really isn't. I have really easy techniques for teaching math. And I've taken people that were absolutely terrible at math and gotten them up to test standards, for the military aptitude tests and everything. And I kind of pride myself in that. When you take somebody and they're like, oh, I hate math, or I'm not very, very good at math. And then they're just like executing questions like pow, just like boom. And, to me, it's a great feeling of accomplishment because I've kind of handed the torch to someone. And they're going to pass it along to somebody else. And then they're going to pass it on to somebody else. And so, if you think this math is hard, it's really not, so I encourage you, just come to the live stream, ask questions. Nobody's going to make you feel like you're slow or retarded or I can't believe you didn't know that question. We don't do that here. My job is to turn the light on in the room. So if you're preparing for the SIFT, ASVAB, ASTB, OAR, AFOQT, FAA, computer test preparation from private pilot all the way up to airline transport pilot, even the certified flight instructor initial, instrument, and multi, whatever you're preparing for, you can come to this channel every Friday night, 9:00, unless something really out of whack happens on my end. But I try my best to be consistent. I try to be here every week for you guys. Because I know that there's people out there that need help. So, like I said, if, you're not doing so great and the preparation is not making sense, you need to deal with a qualified tutor with experience on these exams. It's really, really important, because, I don't know. It's kind of like being equipped to go to war. If you're not equipped to go to war, you shouldn't go to war. You're unarmed. So, why do it? Be prepared properly, but with that being said, I am trying to really close these out on time, and we have about 19 seconds. So if you are interested in the Google Hangout, please send me a request via email, via Skype. If you've dealt with me before, you know me. So, but if you're having problems, all you gotta do is come. I don't understand this. I don't understand that. I will explain it. So I'd like to thank everybody for attending my free live stream. I'll see you guys next week, 9:00 sharp. This is Keno Thomas with STEM with Keno.com. And I was just glancing to make sure that no other comments came out on the message board. But I thank you guys for watching. Have a great night, and I will talk to you guys soon. I should do it from this angle because then, boom, it still caught it.